Hey everybody, this is Kai Wehner from Confluent. Today I want to talk about app modernization in hybrid cloud architectures. We will see different architectures and technologies for integrate applications which are running on-premise like a mainframe or legacy application, and the public cloud including serverless Apache Kafka, and most important, a bi-directional scalable integration between both deployments. And it really doesn't matter on which major cloud provider you're running. What I'm showing you today is true for all of them and possible in the same way. Let's get started. First, I want to talk a little bit about event streaming with Apache Kafka. So if you don't know that very well, so that's important to understand before we talk about hybrid integrations with Kafka, of course. So the rise of event streaming is here for a long time now. So Apache Kafka was created over 10 years ago at LinkedIn. And then over 6 years ago, Confluent was created by the founders, which are the inventors of Apache Kafka, actually. So they got venture capital and founded Confluent to make Kafka enterprise ready. And actually that's what happened, right? So in the meantime, most big companies use Apache Kafka for many different use cases. So this is a little bit about the history of Apache Kafka. But what's much more important for you is what an event streaming platform is and how Kafka works and what it provides. So as you can see in this picture here, so the heart of Kafka is the event streaming in the middle. So this means you can send data from A to B and C in real time at scale for millions of messages per second. But on the other side, Kafka is also a storage system. This means that you decouple the producers and consumers from each other. This is very different from a web service approach with REST APIs or from a traditional messaging queue, because here the queue is deleted after it's consumed. With Kafka, it's really stored so that it can also handle real-time consumers on the one side, but also slow consumers or batch or request response applications on the other side. That's the huge benefit of Apache Kafka. And in addition to that, because it's so scalable, so that you can really process so high volumes of data, like gigabytes per second with one single Kafka cluster, that's in the end the foundation of hybrid integrations and replication between on-premise and the cloud. And also important, Apache Kafka, the open source framework, that's much more. And many people don't know that. So Apache Kafka also includes Kafka Connect for data integration. And it includes Kafka streams for doing continuous processing, also often called stream processing or streaming analytics. And this is often where the real added value comes from, when you don't just send data from A to B in real time, but when you also correlate or aggregate it or use other business logic on top of that. So that's also part of the Apache Kafka open source framework. Many people don't know that. Confluent pioneered event streaming, as I said before, so it was created by the founders or by the inventors of Apache Kafka, and Confluent is doing most of the commits to the project, and therefore most of the heavy Kafka users are working together with us. But what's more interesting than that is actually the use cases we see. And that's super important because Kafka is known very well, maybe 6 to 8 years ago, for data ingestion into a data lake like Hadoop. This is still valid today and a good use case, but only a fraction, maybe less than 5%. In contrary to that, Kafka today is used for many other use cases. And you see here a few examples, and often this is to build a new use case or business platform, which has to run at scale in real time in a reliable way for really the mission critical workloads. Or it is used to modernize the architecture and infrastructure. That's what we are talking about today, where you can build a hybrid architecture, integrate with your legacy systems, replicate data to the cloud for the innovation and elastic scale and cloud native technologies, and then over time maybe even shut down some of the legacy on-premise. The third part of use cases is more like mitigating the risk, like fraud detection or regulatory use cases. As I said, so there's plenty of them, and typically it's combined if you have a Kafka cluster. But I really want to focus on the second one today for migrating to the cloud and modernizing your infrastructure. So let's go to that, and with that, what you will see today is a combination of open source Kafka and also Confluent technologies, which make this hybrid integration and cloud deployment much easier. But what's also important really, I will focus today mostly on AWS because that's what the demo is built for. But exactly the same is true for Azure or GCP, or even a combination of these different cloud providers. So multi-cloud is also what we see more and more, especially in bigger companies. Here's the scenario we want to talk about. So this is hybrid event streaming. This means on the left side, we have a lot of legacy applications, or even if it's modern application, but they are running on premise in a data center. Or in other cases, and I have other talks about that, where you can see that really Kafka is even deployed much closer to the edge, outside a data center, like in a smart factory, or even far closer to the edge, like in an oil and gas field, or in a truck for logistics. So there's plenty of use cases where things are not running in the cloud. And that's the left side, where you can run open source Apache Kafka, or in our case, the Confluent platform, which is based on Apache Kafka. And then on the right side, we have all these innovative cloud services. In this case, we have a lot of serverless services from Amazon. And also in addition to that, you build your custom applications with Java or .NET or whatever it is running in the cloud. And in this case, we're using Confluent Cloud on this side. But what's super important, of course, also is the integration between these both two sides. And instead of doing point-to-point integration, which is really tough and doesn't scale well and is not reliable, we simply use Kafka for this too. So this is a very good solution because on the one side it's an open architecture, but on the other side it's scalable and replicates all the data in real time between on-prem and cloud. And not just in one direction, this is really bi-directionally. And so this is super cool because it leverages all the features of Kafka under the hood, like guaranteed ordering, like handling failover, like if an application is down and starts again, it continues where it stopped before. All of that is built into Kafka and therefore also into this replication. And as I said before, so Kafka is based on Kafka Connect, so it's also an integration framework, like you know it from any other ETL tool or ESB. So with just using Kafka and its ecosystem, you can integrate to all these legacy systems and modern services. So at the edge, you might integrate with a mainframe, or you might integrate with something like another messaging queue. And in the cloud, you maybe integrate with a data lake or with a data warehouse like Snowflake. All of that is built into the Kafka ecosystem. And the big advantage is not just that you don't have to build it by yourself, but that it really also scales very well, it's reliable, and it works in real time. Of course, only if the other system works real time. If the other system is a batch analytics tool, of course, then you also ingest the data in batches. But that's up to the sink or source there. And then the other part, which you can also use Kafka for, you don't have to, but you can, is stream processing to process the data. Here's an example where we don't use stream processing with Kafka native technology. So this means you use Kafka just as messaging and ingestion layer, and then use other tools like Flink or Spark Streaming or Storm for stream processing. And in addition to that, you have other databases. So that's okay if you want to do that. And for some use cases, it's the best solution. But in many other cases, you should ask yourself, do I really need that other solution? Or if I use Kafka anyway for the ingestion and replication, shouldn't I use it also for the stream processing part? And that's what's possible with technologies like Kafka Streams or KSQLDB. So this is the huge advantage of an event streaming platform. Kafka is not just messaging. The core of it is messaging and storage for providing real-time messaging at scale and decoupling of systems. But in addition to that, you all have all these data integration and stream processing capabilities. Here is a real-world example of such a hybrid integration between on-premise with legacy systems and cloud or even multi-cloud for different applications. So this is a deployment at Monsanto, which is part of Bayer AG. And they started a cloud-first strategy a few years ago. And of course, this is a multi-year transition to the cloud. And this shows exactly all these challenges and use cases I showed before. So you need to do data integration to many systems on-premise, but also in the cloud. And you need a reliable and scalable real-time integration, bidirectional, and often multi-cloud, like in this example. And hence, I really recommend you also take a look at that Kafka Summit talk. Here you see, they started early, so this Kafka Summit talk actually is from 2018. And of course, this evolves over time, as you also can see in the right picture. So they start with one kind of use case or pipeline, and then you build more and more integration and connection with Kafka. But this is a super example for building such a hybrid architecture with the event streaming platform as the heart of the integration layer. So let's now talk a little bit more about this modernization and how such a migration can look like step by step. So this is always a journey, like you have seen just before from Monsanto as part of Bayer. So it's a journey and it's in different phases and it depends on what exactly you want to do. We see customers like in this example where they want to get rid of their data center completely because the mainframe and all these things are too monolithic and too expensive and not elastic. But in other cases, there's also plans where this bidirectional replication between on-prem and cloud continues to run because it's important. Like if you're in the manufacturing industry, well, there is always on-premise, right? Because it's tangible goods and you will have data processing at the edge because there it doesn't make sense to replicate all the applications to the cloud for latency reasons, for cost reasons, for security reasons. And hence, what exactly you want to do depends on your architecture. But here's an example of how a customer replicated data to the cloud in phases, but then shut down the on-premise completely. So again, this is the picture we have seen before already. This is the overall architecture. And if we go deeper into that then, and yet most customers we see here are using this called Strangler design pattern. And that's exactly what we recommend to reduce the risk. So you have the starting position on the left side, right? All this legacy on-premise in the data center. And then you build a first application in the cloud. And then you integrate that. And then over time you do more and more of that. And some of you might completely shut down the data center stuff. Some others still have some of that running there. That's totally okay. And that depends on your use case and business model. But this is the overall idea how we see this pattern going. So here is an example now of that. And so this is a deployment where we want to get rid of the mainframe in the data center in the next 5 years. And this is a realistic time frame because you cannot shut down it on a day because it has all the transactional workloads which are super important for your business. So this is how it looks like in the beginning. There's your mainframe on the left side with the core banking system, which runs a lot of COBOL code and things like IMS and DB2 and KIX transactions. And you have applications on the right side. So a first step typically is then to do some kind of integration with Kafka in the middle to these kind of applications, which can then run also somewhere else. So you can also integrate an application in the cloud to that. So here's an example as you see on the right side. And Kafka in the middle is the replication layer. So this means you have a real-time replication, in this case from the mainframe with change data capture into Kafka and from there into the cloud. And then as a next step, what you can do, you can build new applications. Some of them can also be on-premise if that's your strategy, but in this example, we are building new applications in the cloud. And this can be Kafka native applications, like with Kafka Streams or KSQL, where you do real-time processing with Kafka technologies, like these microservices here. But of course, you can also integrate with other big data tools, like you see on the right side. You might use Elasticsearch or Spark, or maybe some native cloud services, in this case from AWS. And it's still all connected also to the data center on-premise. In this case, it's only one directional, but in many cases, you also replicate data back in real time to the data center applications. And then over time, you can replace some of your on-premise applications with a new core banking system and maybe in the cloud. So that's also, again, up to you where it makes sense. But in this case, now we have shut down the old technology and implemented a new version as a next generation with new technologies here. And again, here you see why Kafka shines for this, because it's not just a replication layer, but it also decouples the systems. And you can even run the old and the new system in parallel for some time before you shut down the old system. You should only do that if you know that the new system works very well. And this is where Kafka brings a lot of added value to this kind of architecture and process of doing such a hybrid migration. So let's now take a look at a live demo for that, because that's also really exciting to show you that hands-on. This demo is available on Confluent documentation. Here you see the architecture. We are using a local on-premise Kafka cluster with Confluent Platform, and on the right side we use Confluent Cloud, the fully managed service. And here you see how on the left side we have some data generation, which in the real world would be your data sources, and then we use Confluent Replicator to replicate the data into Confluent Cloud. In Confluent Cloud we use the data to process it with stream processing using KSQLDB. And also we do data integration with a fully managed connector. In this example, I will show you the AWS S3 Connector. So this is a pretty powerful example. Nevertheless, it's very easy to set up. So you can really do this by yourself within 10 minutes or so. You just have to download Confluent Platform, configure Confluent Cloud, and start one script, and that will configure everything for you to see exactly what I will show you now. So I will start with Control Center, which is on-premise, in this case on my laptop. And here we see the on-premise cluster which is running. So here we have some data generation, which is creating data. You can see this here in Kafka Connect, because in this case, as I said before, we are using a data generator. That's, by the way, a pretty cool Kafka connector, open source, which you can use to generate any kind of data. You just configure it in a file, and then it continuously produces the events you want to produce. This is pretty important for testing streaming applications. And that's exactly what I'm doing here. So the important part, however, is that the data which we generated on premise is then replicated into Confluent Cloud using Confluent Replicator. So this is running in this case as part of my on-premise infrastructure, and Confluent Replicator is also based on Kafka Connect, leveraging all of its features like high availability, high throughput, and so on. So this is running on-premise, and we replicate this data to Confluent Cloud. So now I'm in Confluent Cloud, and here you see I have one cluster. In this case it's an US West 2, and you already see that I'm consuming and producing data in this cluster. So let's take a look at that. Here you can see that I started this demo around half an hour ago, and so I'm continuously producing data, and in this case we are getting this data from on-premise via Confluent Replicator, no matter what the data sources on-premise are, because that's separated from the cloud. And then in the cloud, we want to see what we can do with the data. So we have different data flows we can take a look at. So this is what's already running in the cloud with all the different Kafka topics and stream processing applications. To show you one of these topics, so this is the page views. So our logic is around page views and users, and then we can do filtering on that. And here is just a simple message here which we can take a look at. So it has a value, it has a header, and it has keys. So normal Kafka message, right? And the interesting part now is that in the cloud, where we want to process the data, we have already KSQL applications running here. In the same way, of course, you could run any other custom application using Kafka clients like Java or C++ or Python in the cloud. In this case, we use the stream processing framework KSQLDB, and here you see I already deployed a few of these applications, where we have some input Kafka topics like the users and the page views, and then we have some stream processing applications which run continuously. Some of them are stateless and some of them are stateful. And so we can go to streams and to tables to see these applications running. And here you also see that they use different data formats like Afro or Protobuf or JSON. So that's up to you what you want to use. And I just want to show you one example here of such a KSQL stream. In this case, we filter for the female page views, and therefore it's really a straightforward query where the most important part is the where clause, where we say only give me the results where the gender is a female. And the important part, this is a stream processing application. This is deployed and continuously running. And this is Kafka native. This is for high throughput, high availability. Under the hood, this is using Kafka topics, Kafka replication, partitions, replication factor, and all these things you know. So that's already pretty cool. So we have a hybrid architecture, integrating data from on-premise data sources, replicating them to cloud, and doing stream processing in the cloud, all fully managed. And last but not least now, we can even create fully managed connectors in AWS Cloud now. I have already configured an S3 connector for one of the topics. So here you see I have an S3 page views sync connector. And if we take a look at the S3 management console, we see that here we have our bucket for that. And in this bucket, it automatically ingests the data which we create via Kafka. So this is in this case an Afro format. And this is continuously updated. And even this connector from Kafka Connect is fully managed as part of Confluent Cloud. So you don't have to run that. You just configure it. I can show you here, add a new connector, and you see there's a lot of different AWS components. This is sync connectors like Lambda, and also source connectors like Kinesis. And we also, of course, integrate with other systems, like if you use MongoDB on AWS with Atlas, or if you use something like Snowflake or Salesforce. All of them are fully managed. And to show you how this works, you just click on the S3 Connector like I did in my case. You tell the configuration which topics you want to get the data from. And then when you select a topic, then you have to configure a little bit more of the S3 configuration here. And that's it. Then you deploy it and it's fully managed. And so what I have shown you now in a few minutes is really a very powerful architecture and really simple to set up, but to create really highly scalable streaming architectures between on-premise and the cloud. And as I said before, the on-premise solution could also run on AWS Outpost, so you can also have a fully deployed AWS solution in a hybrid way. So I hope you like this demo. I think it's really great to getting started. Yeah, and also what's important, of course, is this demo was with AWS, as we said before. So the same can be done on Azure or on Google Cloud. And also, for example, with Google, it's the same. So, of course, you can then also run the Confluent platform on Anthos, for example. So this is the great part, no matter which cloud strategy you have or where you want to run your applications. And so just to summarize this, what you've seen today is not just Apache Kafka, but really also the Confluent ecosystem. And that's important to understand because we see many customers using Kafka first. That makes total sense, right? And you can do just Kafka, but that's more like what I typically say, the engine of the car. And then in the end, you need to build your own car around that, regarding how to run this, how to operate it, how to make it secure, and all these things. And compared to that, Confluent is more like the self-driving car, which is completely done and works, and you don't have to care about that at all. So that's the beauty of that, and that's all I want to say here, right? So just be aware of that. Apache Kafka is just a piece of the puzzle typically, but especially for these hybrid integrations, if you want to run them mission critical without a lot of efforts and risk, then you typically want to use more than just the open source framework. So, and just one point to make really clear here, and that's because it's really also knowing from my side that many companies use a lot of marketing which is not correct. So from Confluent side, we call Confluent Cloud a fully managed service, which is also the expectation, right? So this means it's serverless, like some other cloud services from AWS or Azure you use, so you don't have to operate them. The big problem with that is that this is actually true for Confluent Cloud, but it's not really true for all the other offerings which are saying the same. So when you go to another vendor, they're also saying they have a fully managed Kafka service, but unfortunately it's not true. So most Kafka as a service offerings are only partially managed. This means you have to select how many brokers you want to run and how many zookeepers and all these things. And then it's provisioned for you on some cloud instances. But then in the end, you have to do all the operations by yourself. And you also have to take the risk by yourself. So some cloud providers even then exclude Kafka support for their Kafka cloud service. This first sounds ridiculous, but some people still don't read the terms and conditions of the service they use. And this is simply what I want to point out here, really. With Confluent Cloud, it's really fully managed. It's serverless and consumption-based pricing with mission-critical SLAs. And that's it, right? And it's also not just Kafka, but really the full platform. Like you have seen, it's also integrating the connectors, which are also fully managed. It's also having data governance tooling and all these kind of things. And then, as I said before, often it's also very important to run in a hybrid way. This means also on-premise somewhere, either in a data center or at the edge. And this is also where these cloud tools often come into play, like AWS Outposts, to run somewhere in a data center but still on AWS technology. And that's why from Confluent perspective, we also partner with these cloud providers to make that happen and fully support it together. And for example, right now, I'm actually also working with the AWS team and some other colleagues from Confluent to build a demo for running on AWS Wavelength, which is in the end their integration into telco carriers to provide a 5G connection with Confluent platform into the ecosystem. So this is really exciting. So therefore, this is still really very complementary between the cloud providers and between what we are doing at Confluent. And then if you are running outside the cloud without a fully managed service, then you have to do a lot of things by yourself for Kafka. And as I said before, you can use just a car engine and run everything by yourself. Or on the other side, what Confluent Platform in a self-managed deployment provides, like on-premise or at the edge, that it takes a lot of the burden and risk for you, like doing the self-balancing of clusters, so that you don't have to do it manually, which is really risky and a lot of efforts. And there is many other features I won't cover today, like tiered storage for reducing the cost on premise for storing the data in Kafka. And then what's maybe even more important also for these hybrid scenarios is that it's not just about running Kafka on-prem and in the cloud, but it's really also about the bi-directional integration between both. And this is again where, of course, you can't do that with open source, and that's totally valid. But if you want to have a battle-tested, fully supported solution, that's also where Confluent comes into play. We've seen the demo with Confluent Replicator, which is established now for many years and used in production at many mission-critical deployments. But what I think is even more exciting is Confluent cluster linking, because that is now the next generation replication, which uses the Kafka protocol under the hood. So this means there is no additional infrastructure needed like Mirror Maker or Confluent Replicator. So this really means you can connect different Kafka clusters by just doing so. And it uses the Kafka protocol to do so. Like you have the replication between your Kafka brokers in one data center. Similarly, it also replicates the data then to another Kafka cluster. And with this now, you can easily build hybrid integrations between a data center and cloud, or also multi-cloud, or between continents, right? So there's different options, and all of them have their trade-offs, of course. But this is what you should be aware of. So that there's very cool and nice solutions to integrate and build these hybrid scenarios with Kafka and event streaming. And with that, I hope this was a good overview for you and that you have learned something, no matter if you're just using Apache Kafka open source or maybe plan to go with Confluent, especially also for Confluent Cloud and its serverless offering. If you have any feedback or questions, let me know. Please feel free to connect on LinkedIn or stay in touch. And so thanks for watching.